Hey guys, today we will be presenting the saturation flow rate, which was written by Damien, Austin, and Dede. The table of contents consists of introduction, the effort, the result, the discussion, and the conclusion. Here is the introduction and the objective. When we collected the data, it was October 2022 at 6:50 p.m. on a Tuesday. Where the location, we decided to choose the intersection of South Marietta Parkway Southeast and Fairgrounds Southeast like our usual location. The reason why we collected this data is to determine the capacity of an approach to an intersection that is controlled by a signal.
As for the effort statement, my name is Damian McHugh. I helped collect data at the site and record. I also did the discussion and the conclusion. Austin also collected data at the site, helped record, and worked on the intro and the results. And Dede worked on the introduction and the results.
After obtaining our field data, we were able to calculate the average headway, which is seconds per vehicle, saturation flow rate, which is vehicles per hour of green, startup delay, which is in seconds, the effective green time, which is in seconds, and lastly, the lane capacity, which is in vehicles per hour. This table shows a comparison of Group 7 and Group 9.5 data. As you can see, Group 7 saturated flow rate is 1,811 vehicles per hour of green, while Group 9.5 saturation flow rate is 1,762 vehicles per hour of green. They both fall in the range from 1,700 to 2,000 vehicles per hour of green.
First, we have the saturation flow rate, which is the number of vehicles per hour per lane. The highway capacity manual has an accepted amount of 1,700 to 2,000 vehicles per hour per lane. Our total saturation flow is 1,811, which falls within the recommended amount. And Group 9.5 had 1,762, which also falls within the recommended amount. The startup delay is the time lost at the beginning of a cycle due to vehicle acceleration. The highway capacity manual has an accepted amount of 1 to 2 seconds. Both our group, Group 7, and Group 9.5 fell within the 1 to 2 second range with a time of 1.16 seconds and 1.76 seconds. Further on, we were able to calculate the final lane capacity, which is the capacity of the approach based on the amount of green time allotted. This is different than the saturation flow, which would be if there was an uninterrupted green. With a capacity of 542 vehicles per hour and Group 9.5's capacity 419, we were able to determine that this is a sufficient amount of capacity for our demand. As for the clearance interval, that is the yellow and all red time used, we only saw it arise in 2 of our cycles, number 2 and 3. And we think this is because there was a large influx of vehicles in the queue. We saw 14 for cycle 2 and 19 for cycle 3. As far as sources of error, one of the bigger ones that we noticed was large gaps in the queue line. Having these large gaps, especially so early on in the queue line, could lead to extended startup delays. Also, as far as calculations go, our effective green time on average was about 35 seconds. However, we did have one cycle that ran to almost 56 seconds, which was the one that was used in our calculation. So with the 56-second effective green time, our lane capacity was our calculated 542 vehicles. However, if that 56-second green time hadn't occurred and it sat more around our average, our capacity based on those numbers would be a little bit closer to 400 vehicles. In conclusion, a saturated flow of 1,811 vehicles with other factors accounted for yielded around 542 vehicles per hour. This is an acceptable amount and meets the current demand, as cycle failure was only measured twice, and that was in cycle 2 and 3. And we think that was due to unforeseen vehicular surges and not because of normal traffic patterns. Because our intersection already has dedicated lanes for each movement, one of the recommendations to improve capacity would be to incorporate a median U-turn crossover. The Federal Highway Administration recommends this because it removes more conflicts that would be caused from that left turn and also completely pulls out that movement, so it reduces the cycle length of the intersection. Pictured on the left is how it would work with our intersection, with southbound traffic making a U-turn at that median, working their way north, and then eventually heading east. This is already a practice that is used further down on Cobb Parkway and South Marietta Parkway Southeast. Here are our references where we cited the Highway Capacity Manual and the National Highway Administration. And that concludes our presentation.